In this video, we are working on this second question before working on the following question in the video after this one, because we like to keep our videos short and straight to the point. That is what we do on this channel. It's basically math tutorials, specifically for like grade 12 learners. But the point is, for more tutorials like this, don't forget to subscribe. We need to prove that CF is like this line over here. We need to prove that CF is equal to this expression on the right hand side. Now in the previous video that we just did, or that you probably just watched, if you haven't, the link to that is in the description. In the previous video we proved that this big triangle here, triangle CBA, is similar to CFB over there. We proved that they are similar using whatever it is that we used right now. With all that being said, this is going to be an easy expression to come up with because of our proportionality theorem. Because anytime you're proving that two triangles are similar, you need to keep in mind that you can always write down that CB over CF, this is equal to BA over FB, which is equal to CA over CB. And then the reason for writing all this is your proportionality theorem and the basics of the proportionality theorem, blah blah blah. You can always get it in the study guide. The link to the study guide is in the description. You can now get it on our website. So, moving on. With all this being said, we clearly want two of our fractions here that have these lines. So, CF, this is CF, ka-ching, and then we need CB. This is CB, this is CB, perfect. And then we need CA. This is CA. I mean, this one is kind of straightforward. It's a bit too straightforward actually. So it's kind of scary, but it's nice. And then I mean, like technically here we want CF on its own. So to get CF on its own, it looks like we're gonna have to cross multiply first. So cross multiplying, you're gonna have CF dot CA here, and then CB squared. See, because CB times CB. Ka-ching, this times this, ka-ching. CF on its own, you can just divide by CA on both sides, and then you have what they want you to prove over there. Now obviously this is like a snippet of a portion in like a full past paper, and for tutorials on like full past papers from start to finish without like leaving anything out, you can just check that in our second channel called Metric Math Past papers. Basically on that channel I basically go through like full past papers from start to finish in like one long video with like timestamps in the description where you can like go to like specific questions, blah blah blah. So you can get that on that other channel as I just mentioned. But anyways, in the next video we're gonna work out a length for FE over there. So for more tutorials like this, as mentioned, you want to subscribe to the channel. And yeah, that's all I can say for now, man. I'll catch you in this video just now. So yeah, you can click on it, it's somewhere on the screen.